Hello everybody, I will start my today's another coding practice. So in this video, I will solve this question, valid parentheses. So in this question, I will be giving a string S containing just the characters, opening parenthesis, closing parenthesis, opening curly brace, closing curly brace, and opening square bracket and closing square bracket. And I will determine if the input string is valid or not. And here, there is a definition of the validity of the string. So open bracket must be closed by the same type of bracket. And also open bracket must be closed in the correct order. Open bracket must be closed in the correct order. So probably this suggests that I see. So this doesn't work. No, open bracket must be. I see. So I think this correct order suggests that maybe the closing bracket must be after the opening bracket. Okay. And for number 3, every closed bracket has the corresponding open bracket of the same time. Yep. So this doesn't work because this closing bracket doesn't have the pair. Okay. Yep. So I think, and again for the point 2, this is not valid because even though I can say this last open bracket is closed, it isn't closed in the correct order. So that's the thing. Okay, so that being said, yep. Let me think of the algorithm. So I will think of the condition I have to meet with some examples. So for example, this isn't invalid because opening bracket comes after closing bracket. So I have to always meet in every index I have to meet for each type of parenthesis. I have to meet open count is more than closing count. And also in the end, I have to make both of them the same. Yeah. And one more thing I have to take care is, okay, wait a minute. So let me think of this for now. So with this condition, I think if the number of types of parentheses is 1, it's always valid with these conditions. However, I have a few, I have 3 types of parentheses. I have to take care of that. And the thing, it will become invalid is like this case. So to filter this out, yeah, I think I can use this algorithm. So I will take a look from the head, and if the parenthesis is closed, I will delete it. I will delete it. And in the end, this one is also deleted. This is a valid case. However, in this case, after this, after finding two, opening parentheses, I get this. And because the opening parenthesis before that is not deleted and remaining there, so I have to think that these two are pair, and actually they are not the pairs. They're not the pair. So this is invalid. So let me use stack and put the element in the stack. And every time the parenthesis is closed, I pop two of them out. And I will continue doing this. And if the newly coming closing parenthesis is not the pair of the opening parenthesis, which is at the top, it invalid. So I can say use stack and yeah. The invalid case is so this case is invalid. And when I think of using the stack and I push element in it, I can say, so basically I push into stack. Yep. And basically every time I see a new character, I push it into the stack. Or if top and new is a pair, I will, you know, pop out. And one thing I have to take care is, in this case, this is invalid. Yeah. So that's it. And also, as I said, I also have to take care of this. So every time closing bracket must be, smaller than or equal to the opening bracket of the same type. And also I have to take care. Oh, in the end, yeah, I have to, pop out all the elements from the stack. Like say, if it is open, open, and close, close, in the third close, second open is popped out. Then in the last close, the first open is popped out. So in that way, the stack must be empty in the end. So that's the basic thing I can say. So let me start implementation with this. So I will define some instance variables, or I should say constant, like this. So firstly, I define the pairs, and also I will define the set of opening parentheses. And I will also define the closing parentheses like this. Okay, so I will use this later. So in line 33, what I have to take care is if the newly coming, char creates the invalid pair. Yeah, and also I have to take care of the. So if I try to do that, I have to take care if there is an element or not, because if there is no element, it's a kind of the edge case when comparing the top, element and the newly coming element. So before this validation, I will quickly do this line 20 validation. So I have to make sure closed count is smaller than open count. And for that, I will keep track of the every unclosed count, here opening count for each parenthesis type. Oh, sorry. Let me do it or I should say, I will use this. So like this. Okay, so what I will do first thing I will do is um wait. This is okay, but I think instead of this, I will keep track of all the count so far. I'm pretty sure this is more understandable actually. Yeah. So the thing is, I every time see a new char, I will push this into the count software, and if count software becomes invalid, then I will return false immediately. I think that is more easy to understand rather than keep track of the unclosed count for each something. So let me do that. Oh, and one more thing I have to confirm is if all the characters in S is parentheses, and this is obviously true. Great. I will implement this later. Yep. So if this is true, I will return false. And if I do that, I can say um, this is met, closed count is larger than open count is larger than closed count. So this means that here, if yeah, stack is length of the stack is 0. Um, it is newly coming char is the opening instance. So with this, I can confidently and safely do line 16 operation. Okay, so let me say okay, so I will check this line 16 condition. Sorry, I think I made it quite complicated. So let me just implement the main method first. So what I should do in my idea is that for every character, first thing I will do is put it into the count software. Then I will check if top and the newly coming element forms a valid pair. So yeah, I think I can do this. It's not so hard. Yeah, know what I mean. So if this is valid, I will just pop the top element and that's it. I'm sorry, let me do this. Otherwise, I will think of the invalid pair. I will return false immediately. Invalid pair means the first one is opening, but second one is closing, but they're not the same type. In that case, I have to return immediately false. Otherwise, I can append this new character, parenthesis, character into the stack. Yep, set it. Okay, then also I have to check, as I said, if the count is invalid or not. Then I will return false immediately. Yep, set it. And in the end, I have to make sure length of the stack is 0. Otherwise, I should return false. But I think this is much more, simple to understand. So let me implement each method. So first thing I will do is if count is invalid or not. So for this, I will take a look at each pair. Oh wait. Then I will check if number of opening is more than number of closing. Or I should say, yeah, this is it. So if opening parenthesis count is smaller than closing parenthesis count, then I will return false. Then, yeah, in the end I should return true by default. Okay, so in line 52, I will check if this is invalid pair or not. So I can do something like, wait, this is super. Okay, so if valid or not, so if C1 is opening parenthesis, which means it is C1 exists as the key of the pairs, and if sorry, if it exists and the pair of C1, opening one, is not the closing one expected, then I will return false. Otherwise, I will return true. And I will now implement is invalid pair. So in this way. So invalid pair is only if C1 is opening and C2 is closing, but C1 is not the pair of C2. So if C1 is opening and then also C2 is opening, I don't say it is the invalid pair. So I would say so this is it. Yep. Oh, sorry, I think. I should make it in rhyme. Probably it would be more easy to understand actually, even though it's longer. Yeah, so this is it. If C1 is opening and C2 is opening, but they're not pair, I will return false. Otherwise, I will return true. Wait, it's invalid pair. Invalid pair. So if they're opening and closing, but C1 is not C2, I will return true. Sorry, I just can't return this. Okay. And when I take a look at line 52, is valid pair not? I will take a look at it again. Yeah, this is correct. Oh wait, so I should do like this. So I can just return this. So C1 is opening and C2 is the pair of the opening C1. In that case, this is true. Otherwise, false. Okay. And in line 35, I found a mistake. If this is, yeah. Oh, this is correct. Sorry. Okay, good. So let me walk through my code with an example. I will send very simple case like this. So in line 32, I start with, okay, sorry, let me do it with this. Or maybe firstly, just this, and also this. So in line 23's case, in line 34, count software is initiated. Then in line 36, I will take a look at closing square bracket. Then in line 37, count software is updated that closing square bracket count is 1. And then line 38, I will call is invalid count method. And now what happens is that for the opening square bracket and closing square bracket pair, count of opening is 0, but count of closing is 1. So this returns false. Then in line 38, this becomes true, and this in the end, this method returns false. Okay, good. Now I will think of this case: open parenthesis, close parenthesis, and closing, square bracket. So in this case, in line 36, first I will take a look at opening parenthesis. And still the count is valid, I can say, like go to line 40, and I will check if this is valid pair or not. Oh no, but in line 40, because length of stack is 0, I go to line 42. Again, because the length of stack is 0, I go to line 44, and I will append the opening parenthesis. Now it looks like this. Then in line 38, I guess the closing parenthesis and count so for closing is now 1. So open and close count is the same now. Yep. And in line 40, this isn't invalid count, so I go to line 42. And I will check if this is a valid pair. So stack top element is closing parenthesis and new character is closing parenthesis. So I take a look at is valid pair in line 57, and open parenthesis in the pairs, and pair of pairs C1 is closing parenthesis, which is equal to C2. So this is true. So in line 42, I come back to line 42, and I pop out the opening parenthesis. Now stack is now empty. Then I get the closing parenthesis, and I'm pretty sure count so far becomes invalid. And in line 40, now false is returned. So this is expected. But let me assume that there is no closing square bracket in this example. I mean, this and this. So in this case, stack is now empty, and I go to line 49, finishing the iteration. Then I return true. So this is expected. Okay, so now I'm pretty confident on my code, so I execute my code. Sorry. I fixed my mistake. Oh, set and set is not expected. Good. So I think this works. Good. Now I submit my code. Okay, now accept it. So I will quickly do the complexity analysis. So for time complexity, this should be O of n, assuming the length of the string is s. Yep, I just have to linear scan each character in the given string. And aside from that, I mean, for each character, every operation is constant time. So it should be O of n. And for space complexity, it should take O of n for stack. Yeah. The stack may be super, I mean, as long as length of the string. In the case when all the, character in the string is opening parenthesis. In that case, I will keep pushing the opening parenthesis in the stack until the end. The length of the stack would be n. So that's just, space complexity. Yeah. So I will quickly wrap up my, summarize my today's practice and then finish. So in this video, I solved the question valid parenthesis, and I'm giving a string s, which consists of only parentheses, opening or closing, and parentheses or curly brace or square bracket. In this question, I use stack. So every time I see a new character in the string S, I basically push it into the stack. But some exceptions are like if the count becomes invalid, which means closing number is more than opening number, I will return false. And also if the top element of the stack is the pair of newly coming character, I mean closing parenthesis, then I pop out the top element in the stack. Otherwise, if top element in the stack and newly coming one forms the pair, but it is invalid, I return false immediately. Otherwise, I put the new character into the stack and keep going. And after the iteration, I will return, if the stack is empty, I will return true. Otherwise, I will return false because it is like, for example, open, open, then close only. Okay, so I finished my today's practice with this. Thank you so much. Bye.